Hey all, today we are introducing LangGraph, a tool that makes it easier to build smart AI systems. While LangChain works well for basic step-by-step tasks, it struggles with more complicated processes. LangGraph solves this by allowing the AI to go back and adjust its decisions, choose the next task based on what's happened before, and handle more complex processes that require multiple steps. And in this video, we will break down how LangChain works for simple tasks but fails with complex ones, and how LangGraph solves that problem. We'll explain the basics of state, nodes, and edges, and why state management is the key to making AI systems reliable. We'll also give you a look at how React agents and multi-agent systems fit into this powerful graph-based approach to building AI. So whether you're aiming for roles like AI engineer, GenAI developer, or ML engineer, mastering LangGraph will give you a big edge in your job search. Also, this video is part of our Agentic AI Mastery Program, where professionals like Utkarsh, Shrija, Devashish, Roshan, and many others have successfully landed high-paying jobs and top certifications in AI/ML. And to know more about it, make sure that you join our free masterclass on AI/ML and Agentic AI. You can register through the link in the description as well as in the pinned comments.
So your AI workflow will mostly in the LangChain. Okay, what we have been doing is kind of a chain which follows a sequential, you can say sequential fixed order of the steps. So let's say if I start, okay, and then it will follow step one, and then that will go to some LLM call maybe, and then will again further go to steps, let's say step number n after doing multiple, and this can be itself looped into a chain. Okay, and finally the last step will end. So this is the kind of workflow, okay, a linear workflow which LangChains can easily create. Okay, but many times this may not be sufficient, although it can still be reliable, but many times it may not be sufficient. You might want to have more complex systems in which the LLM needs to reason and decide the execution flow of the steps. Okay, so what it means is basically, can I jump from step 1 to step 3 directly, or step 5 to step 8 directly? So some kind of these loop back, and even let's say, and this is what the LLM decides. So worst case, if the output of the step 5 is not consistent as desired, then it might want to come back to the step 3 and so on. So all these, loop back, forward, and, so those things cannot be done really in the LangChain. LangChains are pretty linear in nature. So, okay, so let me also illustrate another example. Let's say I have start, and from this start, let's say I have my step 1. Okay, and this goes to some LLM. Okay, this is your LLM brain where all the thinking starts. And I'm just proposing one of the agentic AI systems that we will also be doing, that router based kind of thing. Now, this LLM tries to reason, and then this LLM decides, okay, whether to go for step 2 and then end, or whether to go with step 3 and then end. So here, this is not a linear chain anymore. So LLM takes a call here. So LLM is now literally acting as a router. Okay. So based on the inputs coming from the step 1, okay, it will get to decide whether I want to execute the step 2 or the step 3. So each of these steps will be hard coded, no doubt, but they don't have to, execute in the same order. Okay. So in the case of a completely autonomous system, okay, this can be, multiple steps, hundreds of steps, and the LLM will keep interfering in between and keep deciding which chain to execute back and forth. Okay. So those things will come into picture. So where does LangGraph come? I mean, it will really help you to improve the reliability of these kind of agentic systems where You want more control and also more robustness of these kind of, routing and chaining kind of applications. So let's take one more example here. Maybe I'll just try to draw and show you. Okay, maybe. Okay, so how would the agentic AI system probably might look like? Again, just one another system. Okay, so again, this will also have LLMs and different tools. Okay, so imagine that we have the task defined. So once you have the task defined, that task will be, let's say, given to an LLM. Okay. And LLM can directly give you a response also. Okay. The LLM can directly give you a response after doing some sort of a reasoning. So this is like looped reasoning. Okay. Now, based on the task, this response could be the end of the entire process. But then, let's say this was a question, straightforward question, then the response would be a simple answer. But now, if I'm asking the LLM or the entire agent, so where is the agent? Here, you would have the agent. Okay. So now, if I ask the agent to perform some deep down tasks where the simple response is not sufficient to be the final output of the agent, then agent will decide, okay, to do that task, I will need to use some tools, maybe. So that is where your tools will come into picture. Okay. So this tool will perform some action and that will go to some sort of a environment. Okay. And obviously this environment will give some feedback to the tool, what has happened. So you can think this as a result. Okay. So this is what this red box is ultimately your agent. So your agent is just orchestrating these all things in a kind of a loop back manner. So a React agent will more or less do the same thing. If the agent says to take action, that is call tool, the relevant tools are run and the results are returned to the agent. So if the agent did not ask to run tools, the response output is sent back to the user. That's it. So if there is no need for the tool call, then the response is directly given back to the user. I mean, this is your user side, you can say. This is a user side. User gave a task, and that's where the process started. Okay. So this is like reasoning and action. So I did the reasoning. You can think that this is a reasoning step. And for the action, it just checks, do I need a tool to act or not? If there is no tool needed, then the response itself is the final action. Okay. But if the LLM thinks that, okay, I need some of the tools to actually do some action, then it will make use of those tools and invoke some function calling the action and so on. Okay. Yeah. So that's how it would go. So where is this LangGraph coming into picture? That is built, designed for building agentic applications with much more control. I would say it would offer a low level control, which increases reliability. Number one. Second is like human in loop. Interface is there. It has a persistence layer, which can, not can, but it will enhance the human agent interaction pattern. So we will also see that it will keep on asking some inputs to the human also before getting to the next step, you can say, if needed. Okay. And most importantly, the streaming mode. Okay. So it supports the streaming mode, which means whatever it is thinking and doing, every single thing is streamed to the user so that we exactly get to see what is really happening in real time. And it also gives a feedback to the users about what is all happening in the real time, right? So complex LLM applications can easily created and these kind of cycles will be present in any complex LLM application, you can say. So these cycles will normally use your LLM to reason about what to do next in the cycle. For example, chain of thought reasoning. It could be a simple chain of thought reasoning also. So this will be essentially thought of as you can say running an agent probably as a for loop or in a for loop. You can also think that you are literally running an LLM, sorry, not agent. You are running an LLM in a kind of a for loop. So that is what is being simulated by the agent ultimately. Okay. What else? And then you also have these multi-agentic AI systems. Think of, let me, so this is basic architecture of a React agent. You can see this is a React agent, how it might look like basically. And if you're interested, maybe I can quickly discuss about the multi-agent architecture. So let's say you might have a user, and that user is directly communicating with the supervisor. Okay. Supervisor. Okay. So multi-agent workflow will involve multiple independent agents, which are powered by LLMs. So which means I have agent, let's say one, I would have agent two, and let's say agent three, and all these are communicating back and forth with the supervisor, okay, via these routers. So this is a, okay, these are all your routers, okay. So all these are your routers. So each agent can have its own prompt ultimately. So each agent can have its own prompt. LLMs, okay, so it can have your prompts. It can have LLM. It will also have tools ultimately because agent is supposed to have all of these components and other custom code. So maybe that will handle its memory state, okay. And also this custom code will be needed to collaborate with the other agents, okay. This is code to handle, let's say, memory plus collaboration with other agents. So this is how your multi-agent AI system might look like. Okay. So LangGraph makes it easy because each agent would appear as a node in a graph. Okay. This agent would appear mostly as a node in a graph. And so the control flow can be easily managed by these edges. And we will actually get to see how the communication is happening using the graph state and so on. Okay. Fine. Let's quickly go it from here. So we have used LangChain in the previous sessions, and it's great for linking components in a sequence. That's what one of the diagrams I had made initially. Okay. But now if you want to build more complex cyclical and stateful applications, that is where the LangGraph comes into picture. So let's say you want to go from point A to B to C in a straight road kind of a format, that is where the LangChain comes into picture. But if you have, let's say, a city map, okay, which has intersections, roundabouts, and complete graph, okay, map. So you are starting from here, you want to go here, but there could be multiple ways, routes, and then I mean all sort of navigations are there. So that is where you will need this lang graph. Okay. So it lets you to decide where to go next, what to loop back if needed, and remember where you have been. So all of these can come very, very handy while actually performing that task. Okay. So here we are not building an agent. So we have to understand the state and the state management. That is the objective of this notebook. Once we have understood, then we'll talk about conditional routing. And then we will venture into the tool use LangGraph agent step by step. Okay. So we'll talk about simple stateful chatbot, which remembers the conversation, but then this chatbot is useless as you would see by the end of the notebook because it lacks some of the basic stuff that we will add up in the subsequent, notebooks. So let's understand what is state because I've talked about state a few times now. So state is basically the memory of the agent. What agent has been able to do at any point of time, what all has happened at any point of time. Okay, that uh, you can say that track who keeps the state. Okay, so state is very, very important because looking at the state, agent gets to know what am I supposed to do next? Where am I in this entire workflow? Where do I stand? So if it is a multi-step process, each agent or each step will add something to the state. Okay. So if you have step one, step two, step three, at the end of each step, the state will be updated. At the end of each step, let's say this is my step one. Okay. This is my step two. This is step three. So at the end of each step, the state has to get updated. So at any point of time, let's say now here the agent has reached at this point. So then it looks into the state and knows that, okay, I have completed step one and step two. Okay, now I have to go for the step three. So that is all managed by the states. Okay, so you have to keep on updating the state the moment any action has been performed. Okay, that is as simple as that. So it's a shared object that gets passed between all the steps in your graph. So graph would be like these steps that I'm creating every time. This is your computational graph ultimately. Okay, and that carries information like a conversation history or the tool results. So whatever tool has been used, whatever has happened, what is the conversation with the other tools and LLMs, whatever is the conversation with the user, everything will be mentioned in the states. Okay. So we typically define its structure schema. So this is the main thing. We will typically define the structure or the schema in the form of a typed dictionary. So ultimately it will be like a dictionary. Okay. Just think that it is like a dictionary. So this state is same as we talk to the LLM. See, the problem with the LLMs is they are stateless. LLMs are stateless. Now, what does this mean, LM stateless? They don't remember the previous context. Whatever has happened, what you have previously asked, LLM have no idea. So each API call to the LLM is completely independent of each other. So the application layer has to manage all that conversation, all that memory. Let me repeat it again. API call that you are making to the LLM is stateless. Means LLM has no idea about all any of your previous conversations or whether you are talking about an agent or is it zero shot question asking. No. So it will only see the prompt and behave as per the prompt. That is why it is stateless. It has no idea what you want to do in the complete cycle. Okay. It doesn't have that visibility unless that is clearly mentioned in the context. So it will only be able to see and understand what is within the prompt while making the API call to the LLM. Anything which is not mentioned in the prompt, LLM has no idea. It can't keep guessing. Okay. So which is why we are calling this LLM as stateless. Now, because the LLMs have no idea about what all is happening, if it is a multi-step process and at each step you are using LLM and LLM has no idea about what has already happened, then there has to be a mechanism to keep a track of what all has happened, right? And that is what we are calling it as a state. So LangGraph is able to keep a track of what all has happened in the form of the states because LLM cannot keep that track, right? So every prompt is a fresh or new prompt. Again, it depends. What you want this LLM to do may be different from what you want this LLM to do. So prompts may not be same. At each step, each prompt could be different or would be different because at each step is a agent on its own because now you are saying that this is a LLM, this is a prompt. So, and there could be a tool also. So if there is a prompt, there is an LLM and there is a tool, then each step individually itself is an agent, right? So how would the state? So this state schema doesn't change. So you have to define the schema of this state. I mean, schema means what all you want to store in that state. What all things you want to store in that state, in what format. That is what we are defining in the uh, schema. And usually we use a dictionary kind of a format. Okay. And it will keep a track of all the messages. Okay. The LLM calls and so on. Okay. We'll see that. Hmm. So, and then we talk about the nodes. So node is where all the execution happens. A node is simply a Python function or the LangChain runnable that performs an action. So basically, whenever we invoke a chain, this is the node ultimately at that point. Okay. So actions are performed within the nodes. Ultimately, the actions are performed within the nodes. So when I was drawing these circles were actually the nodes. Okay. So these circles are where the execution happens, and based on that there is some state which will keep getting updated. Okay, so like LLM or a tool call, so the node will decide what to do, whether to go for a tool call or to go with a LLM, or let the LLM decide which tool to be used. So it can be both in a way. So the entire execution happens at that node. Okay. So it takes the current state as the input and returns an output for that state. So after it has, done the LLM or the tool call, the state changed. And so it has to update the state, what all I have done and where are we currently. So that update it has to make for the next node to know what all has happened. So the next node, when the control automatically goes to the next node, okay, it will read the state and find out, okay, we have already done step 1, step 2, and now I am supposed to do the step 3. This is what is expected. And then it will take that prompt, make a API call to the LLM, boss, decide and tell me what all tools will I need to execute this, and I will do the execution. Once I have done the execution, I'll again update the state that, okay, based on LLM's response, I have used so and so tool, and this is the final result that I have got. And so it will again go back and update the state. So the next node again gets to know that, okay, so and so tool was used, so and so thing has already happened, and now this is where we are. So that's like your continuous process, which will keep happening. Okay. Now there can be edges, so connections that define the flow. So basically, this is your edge. This arrow is your edge, and this is your node. Okay, think it this way. Okay, so these are nodes. So you connect the nodes via these edges. Okay. So again, edges can also branch out. Edges can also branch out. Okay. So this is, let's say, node 1. This could be your node 2. It doesn't have to be in the same sequence. And this could be the node 3. So edge links one node to the another, telling the graph what to do next. Okay. So here then this node becomes a router node, because here the LLM API call will decide whether to go in this node or whether to go in that node. Okay. So this can be simple direct links, or it could be conditional. That's what I said. It could be conditional, allowing for dynamic routing based on the current state. So I mean, this could be as simple as one node to another node to another node. This is like a linear flow, or it could be conditional based on some routing. Okay. So all these things are there. Fine. Okay. So going further, so these things will become slowly clear once we actually see them in working. Okay. Now, what are states and state management? Again, I have mentioned that state is the central piece of information that is passed around as the agent works. So that is a shared like whiteboard. Everyone is just writing what all they have done, and the next agent gets to read what all previous agents have written. So state management, that entire process of managing the states and sharing the states across these different nodes and edges, that is what we call as the state management. Okay. So an example is there. An agent state might include the original user question, a list of all the search results so far, a summary of the all the information that has been retrieved by using. So this will come from the tool call. Summarization will come from the LLM, and then the LLM's decision whether the answer is complete or not. If the answer is complete, it will go to the next step, or end, depends whether there is any further need to go to the next step. Otherwise, it will end. And if the answer is not complete, then it will loop back and call the tool once again to look for more research results, let's say. Okay.
So today we have shown you how LangGraph can transform your AI workflows, enabling smarter decision making and handling complex tasks. With LangGraph, AI moves beyond simple sequences to become a real-world intelligent system that can reason, plan, and adapt. Also, if you're ready to take your AI skills to the next level, don't forget to check out our free 90-minute masterclass. We'll walk you through how to land your first AI job, and trust me, you don't want to miss it. Sign up through the link in the description and pinned comments. So thanks for watching, and definitely make sure that you watch this video next.